Welcome back to Advanced Functions, MHF4U1. This is the Combinations of Functions chapter. In this lesson number 4, we're going to represent the quotient of two different functions, both graphically and algebraically. Let's go over the definition of a quotient of two functions. So quotient could be defined by using a fraction button or with the division sign. And what this means is that if the input is same of x, then you can separate it by f of x divided by g of x. With division, it's same thing, but with a different symbol, f of x divided by g of x. And if it's with the fraction button like this, then you could separate it with a fraction as well, f of x, with the straight horizontal line of g of x. So all three of them mean exactly the same thing, but division represented using different symbols. What about the domain of a quotient of two functions? It's exactly the same as what we've been doing so far. The domain of a function f intersects with function g, but we have to keep in mind that we have to say and the denominator g of x cannot be equal to 0, or else it will be undefined. So note, division by 0 is not allowed because any number over 0 does not exist. Question 1. So we are given f of x, a list of points, and g of x, so 3 points. First, determine the domain of f divided by g of x. So let's figure out the domain for f function. It's going to be 1, 2, 4, and 5. Domain for function g is going to be 2, 3, and 5. Well, domain for f divided by g is going to be where they intersect. So it looks like 2 overlaps and 5 overlaps. 2 and 5. Now, but keep in mind that you want to double check that our denominator g of x cannot be equal to 0. So if you look, g at 5, if you look over here, is equal to 0. So therefore, it cannot be the domain. So therefore, the final answer for f divided by g is only 2. Next, so f divided by g, so then it looks like the only point that overlaps is going to be 2. So 2, comma, so at 2 it's 0, f divided by g. So 0 divided by -4. So you have to make sure that you do it in order. And I can simplify this. It's going to be 2, comma, 0. And this will be my new function if I were to do f divided by g. Okay, given, so f of x, so x plus x squared, and we're also given square root x minus 1. So actually, can we replace this with 1? Okay, so 1 plus x squared. And then, yeah. Okay, so now we're doing f divided by g, but the input is 1. So what we could do is f of 1 divided by g of 1. So I'm going to plug in 1 into function f. So 1 plus 1 squared over 1 minus 1. So it's going to be 2 over 0. But anything divided by 0 is undefined, so it does not exist. Next, so this time my input f at 2 divided by g of 2. So I'm going to plug in 2 into my equation. So 1 plus 2 squared divided by 2 minus 1. So that will give me 5 over 1. So therefore, my output is going to be 5 when my input x is 2 when combining by division. Next, so this time, g function is first. So I will be rewriting it as g of 1 divided by f of 1. Okay, so then g of 1, I plug it in. 1 minus 1 is 0 over 1, we said it's going to be 2. So 0 divided by 2 is just 0, and that will be my final answer. So this time, we're now given f of x, 4x, and 2x minus 1. So both of them are linear function. And determine f divided by g. Okay, so I'm going to rewrite this. F of x is 4x. G of x is 2x minus 1. So f divided by g of x, I could rewrite it as f of x divided by g of x. And let's input. So 4x divided by 2x minus 1. And please be careful. You cannot cancel x and x because in the denominator, it's an expression. Okay, so 1 has to contain x in order for me to cancel out. So in this case, this is the most simplified version. But keep in mind, we always have to state the restriction. We cannot make denominator equal to 0, so we say 2 minus 1 cannot equal to 0. So x, when I rearrange, cannot be equal to 1 over 2. So you state the new function and the domain. Okay, and that will be my final answer. Now this time, what if we're given a function in a graph setting? It's the same idea. So you want to pick a point that's pretty clear. So then I would like to pick, let's see, at -2. Oh, so they overlap. So it's going to be, so we could pick this point at -2. We could also pick at -3. And we could pick at, why don't we pick something here? 0, this one, and then this one. And we could pick a point that is, let's say, at 1 and at 3. Oh, so as you can see, we cannot pick points that are on this side because it's hard to figure out the overlap. The blue graph ends here, but I'm pretty sure it's going to continually increase, but it's hard to predict what my y value is going to be. So I will just stop over here. Okay, so after you figure out where the two graphs overlap, for y value, what we're going to do, we're going to do f divided by g. So the red value divided by the blue value. So in this case, the red value here, it's 1 divided by, let's say, -1. Well, not quite -1. So 1 divided by -0.5, 0.9. So that will give me 1.111. So -1.111, so it will be somewhere here. Okay. At -2, it looks like it overlaps. So let's say -0.8 divided by -0.8, it's going to give me +1, right? And over here, I have 2 points that overlap here. also it's going to give me positive 1 because the same number divided by same number is equal to 1. And then here, it's going to be 1 divided by 0. But 1 divided by 0, it's going to be undefined. It does not exist. If that's the case, that means we have a vertical asymptote over here. Okay, because it does not exist. Now next we have, let's say 2.8 divided by 1, and it's going to give me 2.8. Okay, so same thing. And over here we have 3 divided by 2.8. Then that will give me about 1.07. So at 2, let's say it's over here. Okay. Now, so let's try the questions. Let's do one more. So it seems like it's a little bit unpredictable here. So I'm going to combine the point at negative about 1.5. So negative 1 divided by negative 0.6. And that will give me 1.66. So it's going to be at around this point, like pretty high here. Okay, so then now we can connect the dots. So it looks like it's going down this way. And it's going to go down this way. But it's going to approach the asymptote. Okay, not go across it. Same thing here. We know that it's going to be this way. Okay, and it's going to decrease. And assuming that the graph, the blue graph, it's going to increase like this, okay, then we can state that the x-intercept stays as intercept, right? Because red divided by any number, because it's 0, so 0 stays as 0, so it's going to be something like this, approximately. And this is increasing like that. So the purple graph represents the function of a combination of f divided by g. So as always, figure out a point that they intersect, and the x value stays the same. Only the y value, you're going to apply the order of operation. And when you're dividing it, and it gives you does not exist, undefined, that means that's where the asymptote is going to be. And the x-intercepts remain as it is because it's f divided by g. So sorry, so it should be somewhere here. Okay, not this one. Okay, and same thing here, stays as 0, stays as 0. Because 0 divided by any number is going to give me 0. Question 5. So find the quotient of the given function. So, it's the same idea. Now, assuming that we are looking for f over g, and we have to make sure g does not equal to 0. Domain for function f, x can be any real number. Domain for function g, we said that x has to be greater than 0 because it's a logarithmic function. It looks like this. And for this, it looks like this. Okay, so you should have like a visual representation when you're doing domain. So therefore, the domain f divided by g, so where do they overlap? So first, let's do a number chart. For the first one, it could be any number, but for the second one, it has to be greater than g. So it will overlap here. Is that we don't want g of x equal to 0. That means, because log to 1 is equal to 0, right? Logarithm of 1 is 0. So x cannot be equal to 1. Okay, so it has to be an open circle. So it looks like it's in between 0 and 1, or 1 comma, infinity. Okay, so that's the restriction. But what if we were to do domain of G over F? What if we were to do that? That means F cannot be equal to 0, right? So therefore, it's just going to be 0, comma, infinity. Okay? Because the domain for 0 for the first function, x can be any real number. It will never reach 0 because it has an asymptote. So therefore, it's 0, comma, infinity. Okay, good. Next question. So f of x, we're given a parabola and square root. Domain for the first one, it's a parabola, so x can be any real number. So it looks like if I have to draw this, it looks like this. And then for this one, at 1, it looks like that. Domain for function g, x has to be greater than or equal to 1. Okay, so if I have to rewrite this in set notation, it's going to be 1, comma, infinity. So first, we need to figure out where do they intersect. So domain of function f intersect at domain function g is 1, comma, infinity, right? Because the function f can be any real number, so we have to restrict based on the function g. Therefore, so if we're looking for domain f divided by g, we have to keep in mind the g function, it cannot be equal to 0, right? And if you look at it, it's going to be equal to 0 when x is equal to 1. Therefore, we cannot include 1. So it's going to be an open bracket, 1, comma, infinity. Okay. But what if I were to do domain g over f? Okay. So for this case, I don't want f to equal to 0. And f is equal to 0 when x is equal to, so look at your graph. It looks like my y value is 0 when it's at 2. Because if I were to factor this, it's going to be x minus 2, the difference of square, x plus 2. So x-intercept, it's at plus or minus 2. So therefore, it's going to be, so it can include 1, right? 1, comma, 2, or 2, comma, infinity. Okay, so we have to make an exception with 2, and it can include 1 because function g is no longer the restriction to equal to 0. And that will be my final answer.